Hi guys, in this tutorial we are going to talk about a different kind of bonding than we've talked about so far. This one is called metallic bonding. So first we'll cover what that is, so what is a metallic bond and what makes it different than an ionic or a covalent bond. And then we'll talk about something called an alloy, and then we will discuss the properties of metals and why they have those properties. Alright, so let's talk about a metallic bond. So if you remember, metals or metal atoms tend to have a very low electronegativity. And what that means is they don't hold on to their electrons very tightly. And so if we have a sample of a metal, so let's say this is a chunk of something like iron. So these are all iron atoms, and then these are the electrons that are considered their valence electrons stuck to those iron atoms. So the plus signs represent, the nuclei, and then of course the electrons attached to them. Well, since iron's a metal, and metals have a low electronegativity, they don't like to hold on to their valence electrons. And so what ends up happening is those valence electrons get dumped into the spaces in between the atoms, or rather in between the now ions. And those electrons that are now in between these spaces of these now cations or metal cations are free to roam. And what I mean by that is that those electrons are capable of now moving around in the spaces sort of in between those metal cations, and they're not held to any particular atom or ion any longer inside that chunk. A lot of times you'll see, it's hard to draw, but you'll see people draw like arrows to show that those electrons are moving. So we'll define a metallic bond as when all the metal atoms that are in that sample share all their valence electrons with all the other atoms, or with each other. So this is different than a covalent bond, because a covalent bond would just be two atoms sharing electrons between them. In this case, remember, all these electrons are capable of moving in between the spaces of all of these other atoms. So the cations are in place while the electrons are mobile and moving in between those spaces. Okay, so how do you write the formulas for these things? So this is iron, and its formula is just Fe, and you usually see a little S next to it to indicate that it's a solid. Not that that really matters, but notice that there is no subscript. And the reason why is because, a chunk of iron, just depends on the size of the sample, would have a bunch of iron and nothing else. And so we don't give it a subscript because there's not a set number of iron atoms in a particular sample. All right, an alloy. So what's an alloy? Well, here's some examples of alloys. There's brass, bronze, and steel. These are all metal alloys of copper with zinc. So we say that the copper has been alloyed with zinc. And brass, we use brass for a lot of different things. They make fixtures out of them, like for plumbing. They also make jewelry out of it because it looks a lot like gold. But why do we alloy the copper with zinc? Because it changes the properties of the copper, and it makes the copper, for instruments, it gives it a better acoustic tone. And for plumbing fittings, we don't really care about acoustic tone as much as the strength of the copper. So that's why we alloy copper with zinc. Bronze is a mixture of copper with tin. And sometimes there's other elements in there too. And so, here's a picture of a bronze mask or whatever. So bronze we alloy copper with tin in bronze to increase the hardness or the strength. So it increases the strength of the copper and also its malleability. The malleability is just the ability to hammer it out and to shape it. And so that's why we can make, we alloy copper with tin to make statues and stuff. And of course, another example of an alloy is steel. In this case, steel is a mixture of iron with a nonmetal, carbon. And we do that to increase the strength of the iron and use it in infrastructures and buildings and things because it's a bit stronger than the iron that it comes from. And so, it holds up taller buildings. You don't need to know these, but it's just interesting. So alloys, remember the reason that we make alloys is to change the properties of the metal you're alloying. So for example here, bismuth is a metal who can be alloyed into something called Wood's metal. And here's the percentages of bismuth to the elements you alloy it with. And what property are you changing? It's the melting point of bismuth. You're trying to lower it. And they use it for things like fuses and sprinklers. And then you can see that brass is a copper alloy with zinc, like we talked about, and it changes its malleability and its hardness. And you can just kind of see, these are just a list of some common alloys. I thought it was interesting. All right, and lastly, let's talk about the properties of metals. So one of the main properties of metals is they tend to be very shiny. And the reason for this is because these electrons, remember, they're mobile and they can move around in the spaces between the cations of the metal. That means they're not held onto very tightly. So that means incoming electromagnetic radiation or incoming energy can strike these electrons and excite them. And remember what happens to excited electrons. They, when they fall back down, they give off light. And so the reason that metals are shiny is because they're constantly getting excited, jumping, falling down, and releasing these little flecks of light. And we see that as being shiny. Okay, the second property of metals is that at room temperature, most are solid at room temperature. So the only exception to that is mercury. Mercury on your periodic table, on my periodic table, you notice that mercury is written in blue, and the reason that mercury is written in blue is because it's a liquid at room temperature. But all the other metals on my periodic table are written in black because those are solids at room temperature. All right, so most metals are malleable and ductile. So malleable basically just means that you can take a hammer and you can hammer a metal into sheets. They don't shatter. And ductile means that you can stretch metal into long wires. And the reason that metals are capable of this has to do with that sea of electrons, right? So you've always got this little padding of electrons that are in between the cations or the metal ions. So the ions are never directly next to each other because you've got this little padding. And so if this is a hammer and I hammer down on this sheet, it's going to push this down along with the, and the electrons will come with it. And you'll always have like a little cushion of electrons sort of blocking the cations from each other so that they never shatter. Metals also are really good at conducting electricity, which is why we make wires out of them, because we want wires to carry an electrical current. And I don't know if you know this, but an electrical current is a stream of electrons. So I have a little animation that can kind of show you why metals conduct electricity so well. So here you can see that an electrical current is going into a chunk of metal, and those electrons are capable of flowing in between the metal atoms because the metal atoms, or metal ions rather, already have flowing electrons between them anyway, so the incoming electrons and the electrons that already exist between the metal ions are capable of flowing through that metal, which is why metals are so good at conducting electricity. Okay, the last property of a metal that you need to know is that they're really good conductors of heat. So think about, putting a metal spoon into a hot cocoa cup or a cup of hot cocoa. The spoon gets hot with the cocoa because it conducts heat so well. All right, before we end this little tutorial, remember back at the top we talked about these electrons and how they can flow in and around these metal atoms. Well, a lot of textbooks describe that as a sea of electrons. And I just wanted to make sure that I let you know that, because you're going to see that a lot, probably even on the test. And so a metallic bond is metal atoms in a sea of electrons.